Welcome to Computer Networks.
Hello everyone. In this video, we will discuss on Introduction to Multiple Access Protocols by myself. Let us see. We know the importance of data link layer. The main purpose of data link layer is it transmits data from one hop to the next hop. And also the data link layer, the main two functions are data link control and next one media access control. Okay, the data link layer, again it divides into the two sub layers. The first one data link control and media access control. Okay, we know the data link control, what is the process and functionality of each and everything. The data link control deals with the design and procedures for communication. The data link control mainly focus on different functions are framing, flow control, error control and software implement protocols. Okay, in a framing, what are the procedures you have to follow to framing the environment? What are the bit stuffing, char stuffing, and what is the flow control and what is the error control, what are the software implement protocols we have discussed in the previous videos. And coming to the multiple access control, if there is a dedicated link between the sender and the receiver, then data link control layer is sufficient. However, if there is no dedicated link present in the multiple stations, can access the channel simultaneously. So, hence the multiple access protocols are required to decrease the collision and avoid crosstalk. For example, in a classroom full of students, when a teacher asks a question and all the students, here the students indicates the stations, start answering simultaneously, send data at the same time, then a lot of noise is created. So it is the data overlap and the data lost. Then it is the job of the teacher, multiple access protocols, to manage the students and make them answer one at a time. So the below layer, the media access control, is almost control the channel. Okay, right now you can see the upper sub layer in the data link layer, the responsible is data link control, and lower sub layer is responsible for resolving the access to the shared media. If the channel is dedicated, you do not need the lower sub layer. Okay, here the channel is dedicated in between the point-to-point connection, dedicated link in between the two devices. You do not need any lower sub layer, that is the media access control. Here the nodes or stations are connected, use a common link. Here the different stations are using the same network. So it is called a multi-point or multi-drop. Okay, on that time you can need the multiple access protocol, coordinate and access the link. For example, in a traffic, there is no any traffic signal. So the traffic is jammed and also there is a chances for the accidents. So you can stop the collision. We need some multiple access protocols. So the taxonomy of multiple access protocols are three types: random access protocols, controlled access protocols, channelization protocols. In a random access protocols, Aloha, carrier sends multiple access, carrier sends multiple access with collision detection, carrier sends multiple access with collision avoidance. In a controlled access protocols, reservation, polling, token passing. In a channelization protocol, FDMA, TDMA, CDMA, frequency division multiple access, time division multiple access, and code division multiple access. Now we can see the random access protocols. Random access protocols. In the random access protocols, we learn so what is the random access, why you are moving to the random access protocols. In a random access or contention methods, no station is superior to another station and none is assigned the control over another. in random access or contention, where contention indicates the argument in between the different stations, where random access indicates the randomly access the channel. Okay, so in this random access method, there is no any station superior to the another station and also no assigned to the control over the another. Here each and every station act as a primary and combined station. So there is no any bother about that. Okay, here the no station permits or does not permit another station to send. Okay, there is no any control into the other stations. Okay, here each instance, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send. Here, whenever the station has data to send to the other device by using the any medium, here they follow some procedures defined by the protocol, make a decision when can sending or not. Okay, here the two features are used into, it gives the name to the either random or contention. The first one, there is no any scheduled time for a station to transmit. Okay, there is no any time to send a data to for another device without any delay. Okay, the transmission is random among the stations. That is why these methods are called random access. Here the transmission is random among the stations. Okay, each and every station randomly allocate the time slot. Okay, based upon the time they can send the data. That is a random access. The second one, no rules specify which station should send next. Okay, that's why here the each and every station we can that can provide the competent environment. So each and every station adds the medium some competency environment. So that is the methods are also called contention argument methods. Okay, each and for example, any station wants to send the data, each and every station possibly occurred in a competent environment. Okay, based upon the competent environment, the first come first serve based, you can send in their data. Okay, for example, in the random access method, each station has the right to the medium without being controlled by any other station. However, if more than one station tries to send, here's the problem here, if more than one station tries to send, there is an access conflict collision and the frames will be either destroyed or modified. Okay, you can avoid this problem by using some following questions. Okay, to avoid the conflict, okay, or resolve. When it happens, each station follows a procedure that answers the following questions. The first question, when can the station access the medium? Okay. Next question, what can the station do if the medium is busy? How the station determine whether our frame is success or failure during the transmission. Next question, what can the station do if there is an access conflict? Okay, these questions are clearly cleared in next videos by using the random access protocols. Okay, right now, thank you for watching this video.